Hello everyone, today in this video we are going to talk about vector form of Coulomb's law. So after this video you should be able to write the vector form of Coulomb's law and explain the importance of vector form of Coulomb's law. So we already know the Coulomb's law. If two charges are there at distance r, then the force between them is given by F is equal to K, the product of two charges, and divided by square of the distance between them, and K is a constant called electrostatic force constant, and K can also be written as like this 1 by 4 pi epsilon naught, and this is the mathematical form of Coulomb's law. This is the mathematical form of Coulomb's law. Out here if you put the values you may get 1 Newton, 10 Newton depending upon the charge and the distance, but if you see out here we have the magnitude but there is no direction. So we know in vector we need both magnitude and direction. So magnitude is already given by this expression, so we have to put the direction. So vector form of Coulomb's law is given by this. Here you can see now I have cap, so that means it is a vector, and F12 means force on charge Q1 due to charge Q2. So it is given by K Q1 Q2 R square. This is the magnitude, and out here we have the direction, that is R21. So direction is from charge Q2 towards Q1. This is the Coulomb's law in vector form, and this side is the magnitude and this gives the direction. So now let's see the importance of Coulomb's law in vector form. So consider two charges Q1 Q2 and distance between them is R, and suppose R12 is the unit vector going from Q1 towards Q2. Similarly R21 is the unit vector starting from Q2 going towards Q1, and out here both of them are unit vector, their magnitudes are equal and their directions are opposite. So I can write R12 is equal to minus of R21. If these two charges are positive, then Q1 will try to push Q2 with a force like this. So I can represent this force as force on charge Q2 due to charge Q1. Similarly this Q2 will try to repel Q1 with another force going towards this side. So we can write this as force on Q1 due to Q2. So both of them will exert force on each other because they are repelling each other. So now the question may come like this: prove that the Coulomb's law follow third law of motion. So I am taking the same diagram, and Q1 Q2 are the point charges in air, R is distance between them, and other things we have already discussed, and R12 and R21 are equal and opposite because they are unit vector opposite to each other. So force on Q1 due to Q2 will be given by F12, so it will be given by this expression, and the direction will be R21 because see F21 is going towards this side, towards the left, and the vector which is going towards the left is R21. So I just have to interchange this 12 by 21 out here. So similarly the force on Q2 due to Q1 will be given by F12, and it will be K Q1 Q2 by R square. Magnitude will be same, only the direction will be different. So this time direction is towards the right, so the vector going towards the right is R12. So it is from Q1 to Q2, and previous force was from Q2 to Q1. Now from equation 1 and 3 we can write F21 is equal to this, and this R12 can be written as minus of R21 out here. So I have just replaced R12 by R21. Now if I multiply this minus sign in front, so you will get this, and if I take this minus common, now you can see the term inside the bracket K Q1 Q2 by R square into R21 is F12. So I can replace this by F12 using equation number 2. So I can write this F21 is equal to minus F21 using equation 2. Now we can see that these two forces are equal and opposite. So out here this force and this force are equal and opposite, so we can say they follow Newton's third law. That means the forces are equal and opposite, both the charges exert equal force on each other. Second conclusion we can write is these two forces are central force. So you can see these forces are going through the center of each charges, because r12 and r21 are equal and opposite vector. So we can write these forces are central force because they are acting along the line joining two charges. So this is whole derivation in one page. You can pause and copy. Now the importance of Coulomb's law in vector form. Using Coulomb's law we can say that electrostatic force follow third law of motion or Newton's third law, because F21 and F12 are equal and opposite. And using the concept of Coulomb's law in vector form, we can say the electrostatic forces are central forces. So now these are the important questions from this topic. For this question you just need to write the Coulomb's law in vector form, and for this question you have to do the same derivation that we have done, and importance we have already discussed, and the forces are central forces. Now the last question is the important question. There are two charges, one big and one small, and big charge is exerting 5 Newton on small charge, and the question is what is the force exerted by small charge on the big charge, and you have to explain why. So this is the end of the video. Please don't forget to like the video, and I would love to read your comments. Your comments will encourage me to make more videos. Please do write something on comment, and if you are new to channel, please subscribe the channel. And out here I'm giving my phone number. If you need help in any topic, you can WhatsApp me. Thank you.